Hi, everybody, and welcome to the lecture for Chapter 30. We're going to split this chapter into two videos. So the first one is going to be about the beginning of the Industrial Revolution, and that's what this chapter was about. You could see here it says Key Concept 5, and that's because for this unit, this is a heavily covered subject on the AP exam. Okay, so roughly 20% of the exam comes from this time period, and a lot of the information in this chapter is going to be relative to understanding the period of 1750 to 1900. So it's very important that you understand this chapter and a lot of the details, especially as it relates to the key concepts. So for the first key concept of Unit 5, it talks about how industrialization fundamentally alters the production of goods around the world. Not only does it change how goods are produced and consumed, but what is also considered a good. It also has far-reaching effects on the global economy, social relations, culture. And although it's common to speak of an industrial revolution, the process of industrialization was a gradual one that unfolded over the course of the 18th and 19th centuries and eventually became global. So if you read this slide and you look at the introduction to chapter 30 where it goes over the claims for the chapter, right? It's basically introducing the same concept. So this begins, and you should know, if you're going to remember anything for any chapters, it's the introduction. Remember I talked about the claims and thesis and why that's important? That's because it covers the major themes that you're going to need to know. You're going to need to know the Industrial Revolution begins in the 18th century, so the late 1700s, and it starts first in Britain, and then Western Europe, then North America, and then Russia and Japan later. And so it transforms agricultural societies into industrial societies, and that's marked by technological change. And it is made possible by the use of artificial sources of power that lead to the use of machinery in the production of goods. And that's going to lead to economic specialization, large-scale businesses, and over the course of the long run, it's going to also lead to improvements in the standards of living of much of the world. And so, but besides understanding the technology behind it, it's also understanding the unsettling social change that came about through the work environments of the factories, the strict worker discipline, and then also understanding how families were affected. Fathers, mothers, children were pulled into different directions. It alters traditional pattern of domestic life and what the households were like. It changes the lives of women drastically. And later on, we're going to see in the next presentation, in the next video, you'll learn some of the social critics and reformers that try to challenge and improve these conditions. So in this chapter, we're going to focus on the first part, which is the economic impacts of industrialization. So make sure you're paying attention to this lecture and answering the questions that come up as you go through it. So industrialization fundamentally changes how goods are produced, and the energy that we begin to see is coal and steam replacing wind, the water wheel, and then any human and animal labor that's been used throughout history. By having coal and steam, machines are able to run with more power, and they're able to run without getting tired the way humans or animals get tired. And so factories become the form of organization, which is what you see in the black and white photo, over what used to be like a small in-your-house type of cottage industry that you see in the first picture. So rural agriculture is going to decline and urban manufacturing is going to increase. This is going to be made possible by various technological changes that made this possible. And one of those was the improvements in agricultural productivity that began in Britain in the 1780s. So this followed an agricultural revolution where techniques and inventions led to more food surplus. More food was being produced with less workers. So people had more disposable incomes, and you no longer needed the same amount of people out on the farms. So you were growing more food with less workers. And so some of these improvements included how they plowed their fields and how they enclosed off public lands for enclosures to make public land available to private farmers. We see experiments with crop rotation through the four-field crop rotation system. And what this does is this rotated crops to different fields every year, and it allowed the soil to remain fertile and yield high amounts of crops. The agricultural revolution also led to a population growth. And so those population changes in Europe were going to be essential when it came to the need for factory workers. Since less workers were needed on the farm because of techniques, there is now a surplus of labor. And England, therefore, had a lot of people in search of work. So these jobless farmers, they moved to the cities, and they are the labor pool that make manufacturing available. They are the people that are going to get hired to work in factories. And since they need jobs, they're going to be willing to work for very low wages. So understand that we also see why it happens in England is because of the geographic distribution of coal and iron. So understanding why England was first, right? They used to use wood for heat. And so that energy need led to the deforestation of Europe. Britain was rich in coal, and the deposits were easy to access because of all the little rivers that are found in England. So coal begins to substitute wood for fuel, and it supports the expansion of iron production, and iron is going to be important for the use of machinery. England also had a lot of colonies to get resources from in the Americas, in the Indian Ocean, and it was easily accessible by sea. So these colonies provided the land for the raw materials, especially cotton. You should know industrialization begins with the manufacturing of clothes in the textile industry. And the Atlantic provided access and maritime trade. It was getting cheap cotton from the American South. There was also an abundance of rivers and canals that allowed you to connect the raw materials in England to the factories, to the cities where they were. And so it easily allows goods to reach the ports, and rivers provided water power for the earliest factories. Another advantage of England was that it had the accumulation of capital. Maritime trade through like the British East India Company had made England very rich, and it had a strong banking tradition that provided the needed capital to invest in machines and factories. So if someone had a good invention, a good patent, but didn't have the money to start up their own business, England had a banking system that made it easy for them to get the finance they needed, where other countries did not. And so the government policies provided trust in this banking system. Now, the development of the factory system concentrated labor into a single location, and that leads to an increasing degree of specialization. You no longer needed to be an expert in making clothes to work in a factory. See, prior to the use of machineries, you had to be an expert in your craft. If you were making shoes, if you were making clothing, if you were making pots and pans, right? Now you just need to learn to do one thing over and over and just specialize in a little task, as mundane as it may be, because the machines are doing a lot of the work. So prior to industrialization, we had what's called the putting out system, or the cottage industry. And that's where a merchant would take yarn to be spun at a person's house, where they would spin yarn into string. They would take that string to someone who knew how to weave it. They would take the woven cloth to someone to dye it. They would take the dyed cloth for someone to stitch it. And so everyone kind of worked out of their homes in what's called a putting out system, or cottage industry. Factories bring all of this under one roof. So the demand for cotton textiles is going to lead to inventions. As the population grows, there's a need for more cloth. There's a need for more people to buy clothing. And so this forced merchants to figure out ways to make clothes faster. And that's how the factory system slowly came about. It starts with inventions like the flying shuttle, then the spinning jenny, then the water frame, and the power loom. All these inventions, some of which you see pictured here, start to increase how fast you're able to take cotton from the plant and turn it into cloth, right? But as these machines became faster and they became bigger, they also became more expensive. Not everyone could buy them. And the machines became too big to build, to put in your house. And so people who had money were then able to invest in machines and develop the factory system. Like you see here, in the earliest factories were on the sides of river, because this water wheel you see in that first picture turned all the wheels inside that are running the machines that you see in the black and white engraving there. And so that's the development of the factory system. You can see later factories again. You could see a big water wheel on the picture on the left. And then eventually we're going to see the replacing of the water wheel with the development of the steam engine, which is what you see in the factory in the engraving that's shown there, where you see the smoke because it's burning the coal. So now you're bringing all of this under one roof. Now look at the size of these factories, right? These are not something any business person could afford. You have to have more wealth. So there were a lot of merchants and a lot of people who used to work on their own who now cannot compete with these guys and end up having to go work for them in the factories. In the factory, we see the division of labor. So machines required workers to concentrate on one task, like I was saying earlier. So for example, here you see a woman and all she is doing maybe is replacing, the cloth. Once the machine weaves the cloth, pulling it out and putting in more yarn. Other people are in charge of just cleaning the stuff that falls behind the machine. So it's less skills that are required. The use of interchangeable parts allowed workers to focus just on one aspect of manufacturing, right? Just putting one piece or doing one task or hitting one switch or stopping one wheel, okay? So you should be able to describe the working conditions during the Industrial Revolution. Okay, so that's something you should have gotten from the reading, so make sure that in class you're able to do that. Next, we're looking at some of the machines. The steam engine and the internal combustion engine are what make it possible to take advantage of these new resources. And so again, here's a steam engine. You can see how large that engine is. You can see the stairs in that picture. This is a museum, and this is a type of steam engine that was used in a factory. So the energy comes from fossil fuels. First, it's coal at this time. Later on, we begin to use oil. And this is going to have an impact because it's also going to lead to environmental degradation. We're going to start seeing a lot more mining, a lot more polluting of waterways, especially near these mines, and pollution of the air with the burning of these fossil fuels. But the steam engine creates new industries, and the name you should be familiar with is James Watt. And here I am, standing next to a James Watt. So this is a steam engine built by James Watt and his partner. Okay, there's a little video here, and you can skip through this, but you can see the demonstration of how steam power works by watching this video. Okay, and it'll heat up the source, the fuel, and that will evaporate the water, create steam pressure, and steam will turn machines. Okay, so you could pause and play or watch it later, but for sake of time, we move forward. And then later on came the internal combustion engine, which takes the same concept of the steam engine, but instead of using water, you're now creating internal explosions. Okay, this is basically the technology in a car engine today. It's much more efficient than steam. It's powered by burning oil, and it's a lot more powerful. You can make them a lot smaller, and that's why you're able to put them inside automobiles, right? Think of the other machines in the other picture. There's no way you're going to get a car that big. So this leads to then changes in cotton production, because now machines could spin cotton into yarn much faster, and so there's a much higher demand. And you could see between 1760 and 1840 how much raw cotton was being imported to the UK, right? From 2.5 million pounds to 360 million pounds by 1840. And this is another reason why slavery continued in the United States, because slavery was becoming unpopular and it was on the decline, and they had banned the slave trade. But then this demand for cotton puts a lot of pressure on cotton farmers, and so it reinvigorates slavery in the United States and the American South. And then there was a second industrial revolution, they call it, that leads to new methods in the production of steel, chemicals, and new technologies like electricity and precision machinery. Henry Cort devises a method of refining iron ore, and it was the first major advance in iron production since the Middle Ages. And then in 1856, Henry Bessemer develops the Bessemer process that removes impurities from iron to make steel. So steel is a lot stronger, it's flexible, you could bend it and it could still remain very strong, and it replaces iron in structures and machine parts because it's not as brittle. By removing these impurities, if you think of like iron as a solid bar, well, if inside that solid bar there's tiny little specks of air, that makes it brittle and it could break easier. So the less air inside of that metal, the stronger it's going to be. And so you could see iron started to be used in construction, in the construction of buildings and frames. So now we're able to make these really large buildings with wide open spaces, like for the factories, bridges across larger rivers that are much stronger, buildings that are a lot taller than buildings that were made just out of brick and wood. And the Eiffel Tower is an example of this. The Eiffel Tower was designed by Gustav Eiffel. He wanted to show this new technology, this new steel technology, that you could make a giant structure with using a bunch of curved beams. And so there's a lot of bending beams and supports that go into the Eiffel Tower. And it's still around today, right? It's long lasting. When they first built it, people wanted to tear it down because it looked like this ugly metal monstrosity. Of course, now it's one of the most famous tourist attractions in the world. Another new development of the Second Industrial Revolution was electricity and precision machinery. Alessandro Volta creates a steady flow of an electric charge in 1800. That's why we get the use of the word volt when we're talking about electricity, voltage. And then Thomas Edison, 78 years later, and Joseph Swan each invent a light bulb. Edison begins to power streetlights in New York with direct current, one type of electricity. And then 1900s, Nikola Tesla develops alternating current. And so these are two different forms of electricity. Direct current is always on. Alternating current turns on and off, which makes it safer. However, the distance it travels is not as far. And so today, electricity uses both AC and DC. And so that to show that electricity could travel in short little spurts, here you see a picture of Nikola Tesla inside of one of his Tesla coils, showing how it's safe because the electricity isn't always flowing. It's on, off, which makes it safer. That's, the electric car company Tesla is named after Nikola Tesla. And so another aspect of industrialization is that there's major developments in transportation and communication, including railroads, steamships, telegraphs, and canals. And so at first, these steam locomotives were very slow, right? They could carry 10 tons, 70 passengers at 5 miles an hour, which isn't very much, but it's a lot, it's a lot of load compared to what horses can do. And by 1830, the rocket is developed and it goes a whopping 16 miles an hour. Well, again, might not seem very fast to us, but back then nothing had gone that fast and carried that much weight. So now it just becomes a matter of, okay, if we go from 5 to 16, then we could easily get from 16 to 50 and from 50 to 150, right? It creates a ripple effect. And then this leads to new changes. It leads to changes in engineering, in architecture, and all kinds of new jobs. Building the bridges, building the railroads, mining the iron that's needed for the rails, mining the coal that's needed for the steam engine, right? Train stations. And then when there's train stations, towns begin to pop up around the train stations. They need to coordinate the trains. We start inventing the time zone. So between 1850 and 1900, we see the growth of railroads dissecting the continent of Europe, and then eventually other parts of the world begin to develop railroads. That steam engine used in the train is also used in ships. So making steam ships that are able to carry more goods, more people. They're able to make ships bigger, heavier, and then the development of iron, we start making ships out of iron. We also improve communication through the development of the telegraph, Morse code. We begin to put up telephone wires, eventually when we get to the telephone. All of these inventions allow for faster communication of information. And then the construction of canals. So the last thing we'll look at this chapter is, how this increases trade. The Suez Canal was built by the British to allow ships to enter the Indian Ocean via Egypt, and that's the picture that you see on the right. And you can see from the picture, it has two routes, one through the Mediterranean and one going around Africa, which is how ships were going before. So you can see that the Suez Canal cuts your trip down significantly by over 5,000 miles. So your trip is 5,000 miles shorter. Think about what that's going to do if you could make that many more journeys faster, how much more trade is going to increase. And the Panama Canal does the same thing by cutting the trip from New York to San Francisco, cutting across Panama instead of going all the way around South America. It's going to reduce your trip by over 6,000 miles or so. So it allows ships to cut through Central America. And this was used to gain access to raw materials, to control colonies. So these are still vital railways today. And these are massive engineering projects. These were not possible before the development of modern technology and the use of iron and steel. And so there you see the construction of the Suez Canal. So you can see a ship, right, going through the Port Said in Egypt. These are the gates that are being constructed on one of the locks on the Panama Canal. You could see there how enormous those gates are. You know, you could see the people at the bottom. You know, you could see the digging of just through these mountains. There's no water here. This is like a giant pool that's eventually gonna get flooded with water so that a ship could go in and enter another pool. You could see here where the pool will drain and lower the ship to the level of the lake that's adjacent to this. So this is kind of how the Panama Canal takes the ship from the Atlantic Ocean, uses a system of locks like I just showed you, and basically makes the ships move over the land and across to get to the Pacific Ocean. So this takes, about, I would say about 12 hours, maybe a little bit more. But compared to going around South America, it's incredibly fast. So you can see ships going there through the Panama Canal. Okay, so that's it for this lecture. Make sure you understand the impacts, the economic and technological impacts. And in the next lecture, we're going to look at how this impacts people and the changes that come about. Okay, I'll see you at the next lecture.